All right, this time we're provided x equals 1 plus 1 over t and y equals t minus 1. Again, and this curve is parameterized by the parameter t. What I'm going to do is just assign sample values like the way I did in part A till I feel like I get the full picture of the curve by those points so that I can continuously graph it by hand. Okay, so for that reason, I got t values ranging from -5 to 5. Okay, and what I did exactly is just to plug in those t values into plug in those in x and y and get the y and x coordinates of x and y coordinates of the points. Okay, so let's check a few of them out. So t equals -5 here. So that takes you to 0.8 minus 6. Here we go. That is the point. So this point is the very first point I start with. Okay, the next one is 0.75 -5. Here we go. So x is 0.75 and y equals -5. Now let's check -1 at -1. We got the point 0 and -2, and that is on the y-axis, right? So it keeps going like this, right, in this direction. So I had the direction, and if you add more t values, you will see that you are going in this direction, okay? So that's good. So what happens if we plug in positive t values instead? Okay, when t equals 1, you get the point 2 and 0. Here we go. I got this point here. And for t equals 2, I got 1.5 and 1. And for t equals 5, I got 1.2 and 4. Here we go. Okay, so again, I'm going in this direction and in this direction as well. So starting from here, so as you see that my arrow is going north, okay? And this graph has an asymptote, in fact. There's an invisible asymptote here, right? Because when you get closer, when you let t go to -infinity, probably you are going to go to -infinity along the asymptote, and if you go, let's say, if you increase t to infinity, so since we're going in this direction, right? So then probably there's another asymptote over there. Let me just so I try graphing that. Okay, these are invisible asymptotes. I mean, you can sort of like find those asymptotes. There's a way to find them without having the rectangular equation form of this curve, but apparently this is sort of like the visual of the curve. Let me just clean this up for you. Okay, so when you start graphing this, this is sort of like the outlook you should have. Okay, so what I'm going to do next is to get back to the rectangular equation form. So I want to get the classical xy representation of the equation. To do that, I need to solve the equations for t first. And in fact, y equals t minus 1 is sort of like an easy one to do that. So t follows from that as y plus 1, and I can go ahead and plug that back into the x equation so that there won't be any t left in the x equation, okay? So t equals y plus 1. Okay, let's simplify this. Why don't we multiply both sides of the equation by y plus 1, okay? So here we go, times y plus 1. So I have x times y plus 1 equals y plus 1 plus 1. Okay, that takes you to x times y plus 1 equals y plus 2. Okay? So this form of the equation doesn't look like, you know, something familiar to us. Maybe we can use we can solve the other equation first, like this equation. We can solve this equation for t and plug it back into the second part. So let's try that one. Maybe we can get more meaningful stuff. Okay. So first of all, x minus 1 equals 1 over t. Okay. And from that, if you take the reciprocal of both sides, you have 1 over x minus 1 equals t. Okay? Now this looks better because I can plug this t back into the second equation to get 1 over x minus 1 minus 1. Okay? So now this representation is way better than the one we have above, because we can recognize that, and in fact I can tell you that x equals 1 is a problem point that produces a vertical asymptote, because you have 1 over 0 over there. And in fact that was something that we sort of like have seen in the graph, that we have a vertical asymptote here, right, at x equals 1. Okay. And also you have a horizontal asymptote, because as x's approach infinity or minus infinity, right, this term is going to approach 0, and the only term that survives at infinity is -1. So y equals -1 is a horizontal asymptote, and that was another observation we had in the graph. Here we go. Y equals -1 is a horizontal asymptote. Okay, so so yeah, if I were you when I attack those problems, I would try to get the equation of the curve the most familiar to us, so that we can actually grab more properties out of our calculus knowledge about the curve. Okay, so because some properties are known by just staring at the classical or standard form of the equation, like in this case, like x equals 1 is a problem point, it blows up, like the function values blow up, right? But if you look at the parametric curve representation, you can't really see that, right? You can't really see that x equals 1 is a problem. All right. I think this is the end of part B. Please continue watching my next video, because I'm going to talk about part C over there. All right. Bye.